carbon is attached by single bond. So the smallest alkene is nothing but your methane, where one of the carbon atom is attached to 4 hydrogen atoms. So in this normal alkane, when your halogens will be substituted. So substitution is nothing but where one of your hydrogen, at least one of your hydrogen is replaced by your halogens. So halogens are nothing but your Cl, Br, iodine, fluorine, where one of or more of your hydrogen atoms will be replaced by your halogen atoms, and that process will be called as halogenation of alkanes. And this entire reaction will be taken place in presence of light and higher temperature. So normally the halogenation of alkanes is nothing but it is a replacement of hydrogen atoms by your halogens. It is nothing but the replacement of hydrogen by your halogen atoms in presence of heat and temperature. So that will be going to form your haloalkanes. That is going to form our haloalkanes. Haloalkanes are nothing but where your alkanes will be containing your halogen atoms. And this entire halogenation of alkanes is also called as your halogenation of alkanes is also called as the free radical substitution reaction. So your halogenation of alkanes is also called as free radical substitution reaction, because your halogenation of alkanes will follow the free radical mechanism to form the haloalkanes. So just for your normal example, we'll take our methane, the smallest alkane. Then your any one of the halogen will take. So if I write your methane like this, where your 4 hydrogen atoms are there. Okay, so one of the hydrogen atom will be replaced, and instead of that position your Cl will be going to attach. So then what we is going to form is our HCl will be eliminated, and we will be getting our methyl chloride or chloromethyl we are going to form. That methyl chloride, chloromethyl is nothing but your haloalkane, which you are getting after the reaction of your halogens with your alkanes. If one more example if you want to take is your ethane. So our normal ethane, when in react with your Br2, that is nothing but your halogen, then that will form one of your hydrogen atom is replaced by your one of the halogen atom. So that is going to form our CS2, CS3, CS2, Br along with the liberation of our HBr. This is nothing but your ethyl bromide. So like this, the entire reaction of your halogen with alkanes will be taken place in presence of light and at higher temperature. In presence of light and higher temperature, the entire halogenation reaction has been carried out. So the normal mechanism which your halogenation of alkane follows is free radical substitution reaction. I told you na, the replacement of hydrogen with your halogens is nothing but a substitution reaction. Okay, so substitution reaction is nothing but the hydrogen will be removed, and in that position our halogens, any one of the halogens will be coming and attacking. Okay, so it follows the 3 different steps. Your first step is chain initiation. The first step is chain initiation. So in that what happens, your Cl2, whatever Cl2 is there, I have written just like this. Okay, so in Cl2 your Cl2 will undergo homolytic cleavage. In presence of light and temperature, the Cl2 will undergo homolytic cleavage to form our 2 free radical of chloride. So we are getting the radicals of chloride just by the homolytic cleavage of our Cl2, and that is nothing but the entire chain initiation step. Chain initiation is nothing but we are just beginning the chain just by the homolytic cleavage of our free radicals. So that's why I told you na, your halogenation of alkanes is nothing but free radical reaction, because here so many free radicals are going to form. Then your second step is nothing but chain propagation. So chain propagation is nothing but once the chain has been initiated, then the next continuous steps, the further reaction will be carried out. That further reaction is nothing but your chain propagation, is nothing but the continuation of chain will be taking place. How the continuation of chain takes place means the normal your alkanes is going to react with the free radical, one of the free radical. Okay, so that free radical is going to form our next methyl free radical. See, just remember one point. Whenever your free radical atom is going to react with your normal atom, it just transfer its free radical property to that atom also and make that atom as a free radical. Okay, so once it will be reacted, this free radical will be transferred to our methane to form methyl free radical. So that is one of the point you have to remember at anyhow. So here once it is formed, then we are getting CH3Cl plus Cl minus. Sorry, so CH3Cl and so CH3 we are getting CH3 free radical and HCl. Okay, so now what happened? Whatever the previous free radical it was on the chloride, now it has been transferred to your methane to form methyl free radical. Yes, now the methyl has become free radical because it has been gone a reaction with the chloride free radical. So it is a step of your chain propagation. The B step of your chain propagation is nothing but your CH3 free radical, methyl free radical will going to react with the fresh Cl2. So just remember here, 100% of your Cl2, 50% of Cl2 we have used here at the first step, and remaining 50% of Cl2 we are using here. Okay, so this methyl free radical will going to react with our Cl2 to form our CH3Cl plus Cl minus. I told you na, one of the free radical when it react with the normal another atom, it just transfer its free radical to that atom also, and now the same thing has been followed, CH3Cl, and now our Cl has become the free radical. Then here so many steps are there that you have to understand. I'll write here. So many steps are there in chain propagation. This one is our first step, and second step is whatever your CH3Cl and one of the free radical was there. Now again that is going to react with this one to form CH2Cl plus your HCl. Okay, so now what happened? The CH2 has been reacted here so that one of the hydrogen has been eliminated. So one of the hydrogen has been eliminated. Now it will be forming here CH2Cl free radical. Whatever the free radical was here, now it has been transferred to this. Now in a third step what happened? Again same thing you have to take CH2Cl, and now once the HCl has formed, now go with the another fresh Cl2. Okay, then what happens again here? CH2Cl2 and make Cl as free radical. Now it will transfer its free radical over here. Then in our fourth step what happens? Take the same CH2Cl2 and here Cl free radical. See, one step you have to remember. In one of the step, if Cl free radical has happened, in next step HCl has to be released. Next year Cl free radical happens, again HCl has to be eliminated. Like that you have to understand the entire reaction. First Cl free radical, in second step again HCl has to be released. Again where Cl free radical, again HCl has to be released. In that manner you have to understand the entire reaction so that you won't get any confusion here. Then your CH2Cl2 will react with Cl minus Cl free radical, that will give our CHCl plus CHCl2 Cl here. Now our HCl will be eliminated. See here HCl, Cl free radical, again HCl, again in next step we have to get our Cl free radicals. Till how much we have to get means till the entire 4 carbons which is surrounded by Cl minus. So that entire 4 hydrogen atoms will be replaced by your 4 halogen atoms. Till that we have to show the entire reaction. Then your still places are left here. Then what happens? Here CHCl2 free radical. Now HCl has completed. Then again take the fresh one. Then what happens? The CHCl3 and your Cl minus will be free radical. Now here the free radical was there. Then now make your transfer the free radical to your Cl2. Again in sixth step what happens? CHCl3 was there. Again your free radical you take. Then the free radical has to transfer at this carbon. Now what happens? Now what happens? Cl3 plus HCl. Okay, now you have to understand that HCl, Cl free radical, HCl, Cl free radical, again HCl. Now at 7th step, your CCl3 plus HCl completed, then take new Cl2. If it is not visible, I'll just write it here. In your 7th step, CCl3 plus your fresh Cl2. Now what happens? The CCl4 plus your Cl free radical. So in CCl3, your free radical was there. Now it will be transferred to your Cl2. See the entire product, it is nothing but your carbon tetrachloride, where all the 4 hydrogen atoms are replaced by your halogen atoms. That is nothing but carbon tetrachloride. And this entire reaction is nothing but chain propagation reaction. Now we want to end this reaction. Then how we can end this is nothing but that will be we are going to study in chain termination reaction. So third step is your chain termination. During your chain propagation, if your two free radicals will combine each other, if your two free radicals combine each other, then that will form our completion of the entire reaction. Whenever here you have seen that so many, if one compound was free radical, another was no free radical. But when you are two same or two different, I'm saying two same or two different free radicals are coming together, then that will be the termination of our entire halogenation reaction. Yes, so when two of your reactants having the free radicals, then it will be combined to form our product where there is no more free radicals left for the further reaction. Like this, the entire halogenation of reaction will be completed. Thank you so much.